Imagine a galaxy, a collection of stars and dust and gas drifting in silence across the cosmic ocean. It looks delicate, almost fragile, as if a single cosmic breeze could scatter it apart, and yet it remains, floating there against all odds. But here is the unsettling truth. This galaxy is missing something, something vital, something that should make its very existence impossible. It has no dark matter. For decades, astronomers have believed that dark matter is the invisible glue that binds galaxies together. Without it, stars should fly apart like sparks from a fire, drifting endlessly into the void. Without it, galaxies should unravel, dissolve, and vanish into nothingness. But here, suspended in the blackness of space, sits a galaxy that defies that rule. It is a galaxy that should not exist. Take a moment to picture it. Billions of suns hanging in fragile balance, not pulled tightly by unseen forces, but loosely, as if stitched together by threads of smoke. A cosmic apparition. A ghost of a galaxy. The thought alone feels like a riddle whispered by the universe. How can something so vast, so intricate, be both real and impossible at the same time? This is where our story begins, with the impossible. With a discovery that unsettled astronomers, shook the foundations of modern cosmology, and opened the door to questions that still remain unanswered. The impossible galaxy was not just a minor curiosity, not a footnote in the record books of astronomy. It was, in a sense, a tear in the fabric of what we thought we knew about the universe. Astronomers, in their careful way, do not like impossibilities. Science is built on patterns, on the expectation that the cosmos follows rules. Stars move as gravity tells them to. Planets orbit their suns in perfect obedience to mathematics. Even chaos itself can be modeled, given enough precision and patience. But when an observation emerges that does not fit the rules, something strange happens. The scientists pause, then whisper among themselves, then argue, then doubt. And beneath it all, a quiet unease takes root. If this galaxy is real, and if it truly lacks dark matter, then one of the greatest assumptions in modern physics may have to be rewritten. Think of the galaxy as a house. Dark matter is supposed to be the bricks, the heavy foundation that keeps it from collapsing. Ordinary matter, the stars and planets and gas we can see, is more like the paint on the walls or the curtains in the windows, lovely but insubstantial. Without the bricks, there should be no house. And yet, here we stand, staring at a house that appears to be built of nothing but paint. Or imagine a spider's web, intricate and delicate, but invisible in the morning air. The dewdrops that cling to its strands shimmer like stars, but without the web itself, the dewdrops would simply fall away. The web is dark matter. The stars are the dewdrops. Without one, the other cannot remain suspended. And still, here it is, a galaxy hanging in the void with no web to hold it. It feels wrong, doesn't it? Like hearing a song without rhythm, or watching a play with no stage. This is why astronomers were so deeply unsettled. The impossible galaxy was not just a new piece on the cosmic chessboard. It was a move that should not even exist in the game. When the discovery was first announced, many were skeptical. It is one thing to suggest an anomaly, another to claim that an entire category of cosmic structure is missing. Dark matter is not some optional decoration of galaxies. According to every model, it is essential, fundamental, inescapable. To find a galaxy without it would be like finding an ocean without water. And yet, there it was. A faint smudge of light in the telescope, cataloged and measured, showing signs that it was unlike anything else known. The astronomers gave it a name, of course, as scientists always do, though the name itself was ordinary. Just another sequence of letters and numbers, as if such a mundane label could ever capture the strangeness of what they had found. The first time you hear of such a discovery, you may feel an instinctive wave of disbelief. Surely, it is a mistake. Perhaps the telescope miscalculated the distance. Perhaps the stars are being miscounted. Perhaps it is a trick of perspective, a kind of cosmic mirage. But the more you read, the more you realize that the scientists themselves had already asked these questions, had already challenged their own findings, and still the mystery persisted. And here lies the terror of it. If even one galaxy exists without dark matter, then everything we thought we knew about how galaxies form is incomplete. For decades, dark matter has been described as the invisible scaffolding of the universe, the framework upon which all visible matter is draped. Without it, the cosmos as we know it should never have come to be. But if galaxies can emerge without it, then perhaps dark matter is not as universal as we believed. Or perhaps, more disturbingly, we have misunderstood the entire nature of the cosmos. Take another moment to imagine this galaxy again, not as a cold calculation, but as an actual place. Imagine drifting through its star fields. Imagine seeing suns scattered loosely with wide gaps of nothingness between them, as if the galaxy were only half finished, a sketch rather than a painting. The stars are there, glowing softly, but you can almost sense the absence, the missing weight, the invisible hand that should be holding them in a tighter embrace. It would feel eerie, as though you had stepped into a cathedral with no walls, where the ceiling floats unsupported in the air. The human mind is drawn to symmetry, to order, to the comfort of rules. When we gaze at the cosmos, we expect a certain consistency. The laws of gravity, the dance of galaxies, the cycles of stars. But in the impossible galaxy, that comfort begins to unravel. It tells us that the universe still holds secrets that we are not ready to confront. Secrets that may force us to abandon cherished theories, to start again with questions instead of answers. And perhaps that is the most haunting part of all. The galaxy does not shout its defiance. It does not roar against the laws of physics. It simply exists, quiet and serene, a soft contradiction hanging in space. Its very silence is unsettling, because it whispers of a universe that is far stranger, far deeper than the stories we have written about it. This is where the journey truly begins, with a galaxy that should not be here and yet is, with an observation that may be wrong or may be right, but cannot be ignored, with a mystery that sits like a stone in the shoe of modern science, impossible to walk past. But before we can understand why this discovery terrified astronomers, before we can explore the consequences of a galaxy without dark matter, we must pause. We must step back from the riddle and remind ourselves what dark matter truly is and why it matters so much. Because without understanding this invisible shadow, this unseen force that holds the cosmos together, we cannot appreciate the full weight of what it means for a galaxy to exist without it. Dark matter. The very name feels like a riddle. It is not truly dark, not in the sense of being sinister or malevolent. It is dark because it cannot be seen, cannot be touched, cannot be measured directly with any instrument humanity has ever built. And yet, it is there, shaping the universe in silence, guiding galaxies, binding stars, and perhaps even scripting the fate of everything we know. The cosmos is filled with luminous matter, the kind of matter we are most familiar with. Stars that burn, planets that shine by reflection, nebulae glowing with ionized gas, all of these visible to us through telescopes. This ordinary matter, what scientists call baryonic matter, is what makes up you and me, the air we breathe, the earth beneath our feet, the food we eat, every atom of hydrogen and carbon and oxygen. It feels like the most important kind of matter because it is the matter we know. And yet, it is not the majority. In fact, it is barely more than a sliver of reality. Take a moment to imagine a pie chart of the universe. If the universe were divided into slices, luminous matter, the matter of stars and planets and life, would only be a thin slice, maybe 5% at most. Another slice, a far larger one, is made of dark energy, an even stranger phenomenon, a mysterious pressure that stretches the fabric of space itself. But the rest, the great hidden majority, belongs to dark matter. Invisible, untouchable, yet dominating by sheer gravitational presence. It outweighs the stars by a factor of 5 to 1. It is the unseen phantom that sculpts the galaxies. How do we know it is there? The answer lies not in light, but in motion. Imagine walking into a room filled with invisible furniture. You cannot see the chairs, the tables, the shelves, but when you try to move, you bump into them. You trip over them. You feel their presence in every direction, even though your eyes insist the room is empty. This is what dark matter is to astronomers. It does not shine. It does not absorb light, but it leaves fingerprints in the way galaxies move. In the 1930s, a Swiss astronomer named Fritz Zwicky first noticed something strange. He was studying a cluster of galaxies, vast swarms of stars bound together in space, and realized the galaxies were moving too fast. The visible matter, the stars and gas, could not possibly provide enough gravity to hold them together. They should have flown apart like a handful of sand thrown into the wind. But they did not. Something else, something unseen, was holding them in place. Zwicky called it Dunkel Materie, dark matter. Decades later, another astronomer, Vera Rubin, found a similar problem inside individual galaxies. She measured the rotation curves of spiral galaxies, the speed at which stars orbit around their centers. According to Newtonian physics, stars closer to the center, where most of the mass is concentrated, should move faster, while stars at the edges should drift more slowly, just as planets farther from the sun take longer to complete their orbits. But that was not what Rubin saw. Instead, the stars on the outskirts of galaxies were moving just as quickly as those near the center, as though the galaxies were embedded in massive halos of invisible mass. The implication was clear. Something unseen was providing the extra gravity, something that outweighed the visible stars many times over. The case for dark matter grew stronger with every observation. Gravitational lensing, a phenomenon predicted by Einstein's general relativity, allowed astronomers to see how invisible mass bends light from distant galaxies. What they found was striking. Huge clusters of galaxies acted like cosmic magnifying glasses, warping the light of even more distant objects. The degree of bending revealed more mass than the visible matter could possibly account for. Once again, the invisible hand of dark matter was at work, and so the picture emerged. Every galaxy we see, every spiral, every elliptical, every faint dwarf galaxy shimmering on the edge of observation is believed to be wrapped in an enormous halo of dark matter. These halos act like scaffolding, giving galaxies their shape and structure, preventing them from tearing themselves apart. Without this phantom skeleton, galaxies would be fragile things, scattered clouds of stars that would never hold together long enough for life to exist. Dark matter is not just an accessory to the universe, it is its silent architect. Take a moment to reflect on that. Everything you have ever known, every story told beneath the night sky, every culture that has traced constellations and myths among the stars, all of it depends on something no one has ever seen. If dark matter were taken away, galaxies would unravel. The Milky Way itself would dissolve, its spiral arms loosening, its stars drifting out into the intergalactic night. Our sun would lose its place, wandering without direction. Earth would be left behind, alone, a pale blue dot exiled into infinite darkness. Without dark matter, the universe as we know it simply cannot exist. And yet, despite its overwhelming importance, dark matter remains a riddle. What is it made of? Some say it could be weakly interacting massive particles, or WIMPs, ghostly particles that slip through ordinary matter unnoticed. Others imagine axions, ultralight particles that could exist in vast numbers. Some have proposed primordial black holes, tiny gravitational wells formed in the earliest moments of the cosmos. But none of these possibilities has been confirmed. Entire underground laboratories have been built to detect even the faintest whispers of dark matter, but so far, the silence has been deafening. The phantom refuses to reveal its face. This is where the terror returns. Because if dark matter is real, then most of the universe is built from something we cannot see, cannot touch, cannot even define with certainty. It is like trying to describe a house when all you can perceive are the curtains. You know there must be walls, a roof, a foundation, but the structure itself remains invisible. We are surrounded by an architecture we cannot map. And if dark matter is not real, if galaxies like the one we just discussed truly lack it, then perhaps we have been chasing a shadow. Perhaps the laws of physics themselves bend and twist in ways we have not yet grasped. Either way, the universe is stranger than our textbooks suggest. Stranger than the tidy diagrams and neat equations that try to pin it down. It is a place where the majority of its mass is hidden from sight, where galaxies spin in defiance of visible gravity, where clusters hold together by forces no one has ever directly touched. So here we are, standing at the edge of this mystery, knowing that galaxies are supposed to be built on invisible skeletons of dark matter, halos so massive they outweigh the stars themselves. And now, with this knowledge heavy in our thoughts, we must return to the question. If every galaxy is supposed to have this phantom skeleton, then what does it mean when one appears without it? The story begins, as so many of our most unsettling discoveries do, with a small observation that refused to stay small. It was the year 2018. Astronomers were using the Hubble Space Telescope, one of humanity's most trusted eyes on the cosmos, to study galaxies in the neighborhood of a massive elliptical system called NGC 110 The expectation was routine. They would observe faint smudges of light, catalog their positions, measure their shapes, and continue adding threads to the great tapestry of cosmic mapping. Nothing unusual, nothing alarming, just more careful work in the quiet pursuit of knowledge. And yet, within this field of view, something unexpected shimmered. It was a galaxy, but not like the others. Not bright and tightly bound, not filled with the familiar swirling arms of stars, but pale, transparent, almost see-through. It looked less like a galaxy and more like a ghostly impression, a faint breath on the windowpane of space. The astronomers cataloged it as NGC 1052 DF2. The numbers and letters are ordinary, just part of the endless bookkeeping of the sky. But behind that sterile label lay something that would unsettle the very foundation of cosmology. DF2 was not just faint, it was peculiar. At first glance, it seemed to contain far fewer stars than a typical galaxy its size. Its shape was diffuse, extended, as though someone had taken a normal galaxy and stretched it thin, leaving its stars scattered like grains of dust. If a normal galaxy is a glowing city of light, clustered and vibrant, then DF2 is a ghost town, its houses crumbling, its streets empty, the faint glow of lanterns flickering without warmth. But what truly caught attention was not its appearance, but its weight. Or more precisely, its lack of weight. Astronomers can weigh galaxies in indirect ways, by studying how fast the stars move inside them. If there is a great deal of mass hidden beneath the surface, the stars should move quickly, racing under the pull of strong gravity. If there is little mass, the stars move slowly, drifting with less urgency. In DF2, the stars were moving far too slowly. Their measured velocities suggested that there was no hidden reservoir of dark matter providing extra gravity. What you saw, faint and fragile, was essentially what you got. The realization was chilling. For decades, astronomers had believed that galaxies cannot exist without dark matter. Dark matter was the scaffolding, the skeleton, the invisible hand that gathers stars into galaxies and keeps them bound together. Without it, the stars should have dispersed long ago, scattered across intergalactic space. And yet, here was DF2, floating serenely, calm and coherent, seemingly held together by nothing more than the luminous matter visible to our eyes. Imagine, for a moment, looking at this galaxy yourself. Through the lens of Hubble, it would not strike you with dramatic beauty. It would not blaze with color like the grand spirals we so often admire in astronomy books. Instead, it would feel fragile, almost insubstantial, as if you could reach out and pass your hand straight through it. A wisp of cosmic smoke. A fragile breath frozen in the void. And yet, within that fragility, there lies defiance. DF2 is a galaxy that should not exist, and yet it does. For astronomers, the discovery was electrifying and unsettling all at once. If dark matter is truly universal, then this was the exception. And exceptions, especially in science, are dangerous things. They are like cracks in a dam. At first small, almost ignorable, but if left unexplained, they widen and the whole structure begins to break. DF2 was not just a curiosity. It was a potential crack in the great dam of cosmology. Skepticism rose immediately. Could the measurements be wrong? Perhaps the galaxy was not as far away as they thought. If it were closer to Earth, then its stars would not be as luminous as assumed, and its mass could be underestimated. The illusion of missing dark matter might dissolve under more accurate calculations. Others suggested observational errors, misinterpretations, or unusual alignments with background galaxies. The universe often plays tricks on us, after all. But as the data was checked and rechecked, the evidence remained stubborn. The stars in DF2 were simply not moving fast enough to indicate the presence of dark matter. It was as though the invisible skeleton had been stripped away, leaving the galaxy naked and exposed. This is where the story begins to stretch the imagination. If DF2 truly lacks dark matter, then one of two unsettling possibilities must be true. Either galaxies can form without it, a notion that overturns decades of theory, or dark matter itself is not the universal law we have assumed it to be. In either case, the consequences are profound. Take a quiet moment now to reflect on the strangeness of this. The universe, so vast and so ancient, still holds surprises that can make experts pause in disbelief. Humanity has built great instruments to probe the cosmos, sent probes beyond planets, peered into the afterglow of the Big Bang itself. And still, a faint ghost of a galaxy can appear, and with it, bring an entire field of science into question. That is both humbling and haunting. The astronomers who discovered DF2 did not claim final answers. They published their findings cautiously, inviting scrutiny, aware of the storm it might unleash. And unleash it did. Debates flared across the scientific community. Was this truly a galaxy without dark matter? Or was it a trick of perspective, a misstep in measurement? The journals filled with arguments, rebuttals, and counter-rebuttals. The galaxy itself, silent and distant, drifted on, indifferent to the commotion it inspired among the tiny creatures on one small blue world. But for those who allow themselves a moment of wonder, DF2 is more than a scientific puzzle. It is a reminder of how fragile our understanding is, how provisional even our most cherished theories can be. The cosmos does not owe us consistency. It does not promise to fit neatly into our equations. It presents itself as it is, strange and enigmatic, and leaves us to struggle with the implications. And perhaps that is the most beautiful part. The ghostly galaxy, transparent and ethereal, teaches us humility. It whispers that the universe is not yet fully written, that the book of nature still has blank pages waiting to be filled. It reminds us that wonder often arrives not with loud discoveries, but with quiet contradictions, faint smudges of light on a telescope image that refuse to make sense. NGC 1052 DF2 stands as one such contradiction, a ghost in the telescope, a galaxy that should not be. And like all ghosts, it leaves us with questions that unsettle our certainty. If dark matter is supposed to be everywhere, then how can this galaxy exist without it? If dark matter is the rule, then what does it mean when the rule is broken? And here we reach the next step in the mystery. Because dark matter cannot be seen, only inferred, the real question becomes, how can astronomers be so sure? How do they measure what cannot be touched? How do they claim a galaxy has no dark matter when dark matter itself is forever invisible? The answer lies in methods as clever as they are delicate, in weighing the invisible by watching the motion of the visible. And to understand this, we must follow the astronomers deeper into the tools of their trade and explore how one can measure a ghost. There is something almost paradoxical about studying the universe. The objects are impossibly far away, scattered across billions of light years. And yet, from the faint traces of light that reach our telescopes, we claim to know their size, their age, their weight. It is an audacious act, really, to weigh galaxies made of stars and gas so distant that no spacecraft will ever touch them. And yet, astronomers have found ways to do precisely this, to measure what cannot be touched, to weigh what cannot be placed on a scale. The challenge, of course, is that dark matter is invisible. No telescope, no camera, no detector of photons will ever capture its glow, because it does not glow. It does not shine. It does not reflect. It does not absorb. It slips past our eyes like a phantom. If you were to drift through a halo of dark matter yourself, you would notice nothing. No resistance, no shimmer, no sensation of being bathed in something alien. It would be like swimming through nothing at all. And yet, its gravitational pull is unmistakable, written in the dance of the stars it shepherds. To weigh the invisible, astronomers turn to motion. Imagine a child's merry-go-round, spinning faster and faster on a playground. You place your hand on its edge, and the harder it spins, the stronger the force that pushes against you. You do not see the force, you only feel it. But from that sensation, you can infer how much energy and momentum is at play. In the same way, astronomers look at how fast stars orbit around the center of a galaxy. The faster the stars move, the more mass must be hidden inside, holding everything together. In principle, the method is simple. You measure the velocity of stars, compare it to the visible matter in the galaxy, and from the discrepancy, you infer the dark matter. But in practice, it is an act of exquisite precision. Astronomers examine the spectra of starlight, tiny shifts in wavelength caused by motion, like the change in pitch of a siren as it passes by. From those shifts, they deduce how quickly the stars are moving, how tightly they are bound. Every data point becomes a clue. Every faint smudge of light on a graph, another piece of evidence in the puzzle of cosmic mass. For most galaxies, the pattern is clear. Stars move far too quickly to be explained by visible matter alone. The gravitational pull of the luminous gas and stars is not enough. Something else, unseen, must be weighing the galaxy down, keeping its stars from flying apart. That something is dark matter, inferred by the very fact that the galaxy holds together when the laws of physics say it should unravel. But then came DF2. When astronomers turned their instruments on this faint, ghostly galaxy, the results were startling. The stars were moving far too slowly. Their velocities did not hint at hidden weight, did not whisper of a great invisible mass beneath the surface. Instead, they suggested the opposite. What you saw in DF2, faint and fragile though it was essentially all there was. No massive hidden halo, no skeleton of dark matter wrapping it together. Just stars drifting, calmly and loosely, as though nothing heavier bound them in place. It was as if you placed your hand on the spinning merry-go-round, expecting it to shove you with hidden force, only to find it moved lazily, with no extra weight at all. It was as though the cosmic furniture had been cleared from the room. Astronomers looked for the telltale fingerprints of dark matter and found none. Pause here for a moment and consider the strangeness of this. We are accustomed to thinking of absence as a lack of data, a gap in knowledge. But in astronomy, absence can be a discovery of its own. To find a galaxy without dark matter is not merely to see less, it is to glimpse something that fundamentally challenges the very methods we use to weigh the cosmos. DF2's stillness, its gentle motion, was not nothing. It was a statement. A quiet but powerful contradiction, telling astronomers that the rules might not be universal. Of course, science thrives on doubt, and so the questions began. Could the velocities have been miscalculated? Could background galaxies, overlapping in the telescope's field of view, have interfered with the measurements? Could DF2 be closer than estimated, its stars dimmer and lighter than assumed, creating an illusion of missing mass? The act of weighing the invisible is delicate, and even a small misstep can lead to an enormous misinterpretation. Yet the more carefully astronomers examined the data, the more stubborn it became. The measurements were checked, recalculated, challenged from every angle, and still the stars of DF2 drifted slowly, too slowly to hint at hidden mass. It was as though the galaxy itself was whispering, "Here I am, fragile and transparent, yet whole. Here I am, defying the rules you thought were unbreakable." For the wider scientific community, the implications were dizzying. If DF2 truly lacks dark matter, then the relationship between galaxies and their invisible halos is not absolute. Perhaps dark matter can be stripped away. Perhaps galaxies can form under different rules than we imagined. Or perhaps dark matter is not what we think it is at all. Every possibility was unsettling. Every option bent the framework of modern cosmology. There is a quiet kind of terror in this. Not the terror of immediate danger, but the deeper unease that comes when the ground beneath your understanding shifts. The scales we use to weigh the universe, the methods that seemed so reliable, suddenly feel less certain. The invisible can be measured, yes, but what happens when the measurement defies expectation? What happens when the ghost you are chasing refuses to appear and instead leaves only the echo of absence? Imagine for a moment drifting through DF2 yourself. You float among its stars, each one separated by immense gulfs of darkness. There is no sense of compression, no gravitational tension pulling you into tight orbits. The galaxy feels light, airy, almost hollow. It is not chaotic, not collapsing, but tranquil in its sparseness. You would feel the absence as a kind of stillness, a serenity born not of strength, but of fragility. It would be like walking through a cathedral with no pillars, the roof hanging impossibly in the air, supported by nothing you can see. And yet the galaxy persists. This is what makes it so haunting. It is not in the process of falling apart, not visibly tearing itself into pieces. It exists, coherent, steady, as though it has discovered some other way of being. That persistence is perhaps the most unsettling weight of all. In the end, the act of weighing the invisible brought us not clarity, but contradiction. Astronomers expected to find the usual signs of dark matter, the hidden gravity that binds the cosmos, but instead they found stillness. They expected a heavy skeleton, but instead they found only fragile light. And so the question remains, is DF2 truly what it appears to be, or is it an illusion born of distance and perspective, a cosmic trick that misleads our instruments? Perhaps galaxies are trickier than we think, disguising themselves in ways that lead us astray. Which brings us to the next step in the story, for the universe is rarely so simple. When something seems impossible, the first thought is always to ask, could it be a mistake? Could DF2's ghostly appearance be nothing more than a mirage? Astronomy has always been a discipline balanced on the edge of perception. Unlike laboratory sciences, where experiments can be repeated with precision under controlled conditions, astronomers must work with whatever the universe sends their way. A trickle of photons, ancient and weary, crossing millions of years before arriving at the mirror of a telescope, a dim smudge against the black canvas of space. From this faint signal, entire stories about galaxies, stars, and cosmic history are constructed. And because so much depends on so little, the slightest error in interpretation can create illusions that ripple across science. This fragility is why some astronomers wondered, when confronted with the ghostly figure of DF2, whether the anomaly was not real at all, but a mirage created by perspective. The idea was simple, almost comforting. Perhaps the galaxy was not as far away as first believed. If its distance had been overestimated, then everything else, its size, its brightness, its mass, would have been distorted by the error. To understand this, picture watching a lantern glowing faintly in the distance. If you assume the lantern is a mile away, its faintness tells you it must be incredibly bright to appear at all. But if it is only half a mile away, then its faintness makes sense. It is dim because it is simply close and weak. Distance transforms perception. The cosmos plays the same game with starlight. Dim stars might be faint giants far away, or they might be small embers much closer. Without the right frame of reference, the human eye cannot know. So what if DF2 were closer? If the galaxy sat nearer to us than assumed, then its stars would be intrinsically dimmer, its structure smaller, its gravitational balance more ordinary. The illusion of a giant ghost drifting without dark matter would dissolve into something far less dramatic, a modest galaxy behaving just as physics demands. The terrifying possibility of a dark matter-free existence would evaporate with the correction of a single number: distance. It was a tidy solution, one that eased the unsettling tension DF2 had created. After all, the cosmos has fooled astronomers before. Distances are notoriously difficult to measure, especially for faint galaxies on the edge of detectability. Astronomers use a toolkit of methods: measuring redshifts, identifying standard candles like certain kinds of stars whose brightness is well known, comparing relationships between color and luminosity. Each method is ingenious, and each one is vulnerable to error. Imagine looking through fog at a row of streetlights. Their spacing, their brightness, their apparent size all shift with the density of the mist. You might swear that one light is farther than the others, only to discover later that it is closer but smaller, or brighter but more obscured. Galaxies, observed through the haze of intergalactic distances, behave in much the same way. For DF2, the debate grew lively. One group of astronomers argued that the galaxy was indeed much closer than originally thought, by millions of light years. If they were right, then the anomaly vanished. DF2 was no longer a ghostly skeleton defying physics, but a mundane cluster of stars whose dark matter was simply harder to detect. The case would be closed, but others were not convinced. Independent teams revisited the data, measuring and remeasuring, cross-checking methods against each other. They pointed to the shapes of globular clusters within DF2, ancient knots of stars whose luminosity provided a kind of cosmic yardstick. They studied surface brightness fluctuations, subtle variations in light across the galaxy that hint at its distance. They analyzed the redshift, the stretching of light as the universe expands. Each method carried uncertainty, but together, they painted a consistent picture. DF2 was not closer. It was exactly where it first appeared to be, tens of millions of light years away, in the shadow of a much larger galaxy. The debate was fierce, because so much was at stake. If the closer distance hypothesis were true, the unsettling implications of DF2 would fade. Cosmology could exhale again. But if DF2 truly sat at its original distance, then the mystery deepened, demanding explanation. In that tension, one could sense the vulnerability of human knowledge, how entire theories can hinge on the interpretation of a faint signal drifting through the night sky. Take a moment to reflect on that. Our understanding of cosmic structure, of invisible forces shaping the universe, rests on light so faint that a minor calibration error could shift it into another category of reality altogether. What appears revolutionary today might dissolve tomorrow into an error of perception. It is humbling. It is also strangely beautiful. The fragility of cosmic knowledge mirrors the fragility of the galaxies themselves, thin webs of stars stretched across unfathomable distances, holding together against the dark. For months, the possibility of a cosmic trick of the light hovered over DF2 like a shadow. Scientists traded papers and debates, sharpening their arguments, refining their calculations. And as they did, the galaxy itself remained silent, its faint light continuing to drift toward Earth as it always had, unaware of the commotion it had caused. But then something unexpected happened. As if the cosmos, tired of the argument, decided to add a twist of its own, another galaxy appeared. Another faint, ghostly smear on the Hubble images. And like DF2, it too seemed to lack the dark matter that should have been its foundation. The discovery sent a shiver through the community. One galaxy without dark matter might be a trick, a mirage of distance and measurement. But two, that was harder to dismiss. It was as though the universe were whispering, "No, this is not an error. Pay attention. The rules you thought were certain may not be so certain after all." The debate over DF2's distance suddenly mattered even more because its sibling galaxy reinforced the possibility that something deeper was at play. Illusions are easy to imagine once, but harder to sustain twice in precisely the same way. The question shifted from, is DF2 a mirage, to what are we missing about the true diversity of galaxies? And so, the mystery grew. What if some galaxies really do exist without dark matter? What if the invisible skeleton is not as universal as once believed? What if the architecture of the cosmos is more flexible, more chaotic, more unexpected than the models allow? Weighing the invisible had already revealed contradictions. Now, the possibility of a cosmic trick of the light hinted at something even more unsettling. That the universe might enjoy playing with our expectations, presenting us with riddles that dissolve only to reform in new and stranger shapes. The stage was set. The story of DF2 was no longer about a single ghostly galaxy, perhaps misunderstood, perhaps mismeasured. It was about a pattern, faint and emerging, that suggested an even stranger truth. And so we are left with a question. If one phantom galaxy can be dismissed as an error, and two cannot, what does it mean when the cosmos reveals its duplicity not once, but twice? If the cosmos had been content to leave us with one puzzle, the mystery of DF2 might have slowly unraveled under the patient weight of scientific debate. Perhaps it would have been filed away as a case of mistaken distance, a measurement too imprecise, a misinterpretation destined to be corrected with better instruments. Science is familiar with such errors, but the universe, in its quiet way, is rarely so merciful. Instead, it doubled down. Not long after the faint ghost of DF2 unsettled astronomers, another apparition appeared in the darkness. Another dim, sprawling collection of stars that seemed to float without the hidden scaffolding of dark matter. This second object was christened NGC 1052 DF4. Its name was plain, clinical, yet what it represented was anything but ordinary. For here was a twin to DF2, born in the same neighborhood of space, whispering the same troubling message. The discovery was like lightning striking twice in the same spot, an event so improbable that it forced everyone to pay attention. One galaxy without dark matter could be dismissed as a trick of perception. Two galaxies, separated by light years yet linked by their defiance of cosmic law, were harder to explain away. Coincidence seemed less likely. Something was happening here, in this quiet corner of the cosmos, that threatened to rewrite the rules. The galaxies themselves were haunting in their similarity. Both were faint and diffuse, so transparent that distant galaxies could be seen right through them, as though their stars were scattered smoke across the night. Both floated near the massive elliptical galaxy NGC 1052, a cosmic giant whose gravitational field may have shaped their fate. And both carried that same absence, that same refusal to show the hidden weight of dark matter that nearly every other galaxy revealed. The shock among astronomers was palpable. The discovery of DF4 was not just an addition, it was an escalation. If DF2 was strange, DF4 made it stranger. If DF2 could be dismissed, DF4 made dismissal nearly impossible. It was as if the cosmos itself were insisting that we take the anomaly seriously. Two galaxies, side by side, quietly dismantling our assumptions. Take a moment to imagine this strange pair, drifting together in the void, delicate and insubstantial, like two wisps of cosmic breath. They are not brilliant spirals like the Milky Way, their arms filled with glowing nebulae. They are not dense spheres like globular clusters, burning with concentrated light. Instead, they are faint, wide, and fragile. Their stars are spread thinly, like sand scattered by the wind. And beneath that fragile veneer, there is nothing else. No unseen skeleton, no invisible glue. The impact of this was immense because science depends on patterns. A single outlier can be chalked up to error. Two outliers, especially two that share space and circumstance, hint at a deeper law. They suggest that what seemed impossible might actually be natural, though hidden from view until now. Was it coincidence, then, that DF2 and DF4 both lived in the same celestial neighborhood? Or was there something profound about their environment? Something about their proximity to NGC 101052 that stripped them of their invisible skeletons? Some astronomers began to suspect that these galaxies were victims of cosmic theft, that their dark matter had been pulled away by gravitational interactions with their giant neighbor. Others wondered whether they had formed differently from the start, born without the usual veil of dark matter, proof that the universe could write galaxies in more than one script. The philosophical implications were no less unsettling. If galaxies could exist without dark matter, then dark matter was not the universal rule it had once seemed. Perhaps it was more fragile, more susceptible to environmental conditions than imagined. Or perhaps the very concept of dark matter needed revision, a sign that we were still groping in the dark for something we did not fully understand. For the wider public, the story had the texture of a ghost tale. Two galaxies, pale and transparent, drifting side by side in the void, refusing to obey the laws that bind the rest of the universe. They were like twin phantoms, whispering a secret no one could yet decipher. Even the names, DF2 and DF4, felt like code in some cosmic riddle, their simplicity masking the enormity of their implications. Scientists, of course, resisted the temptation of mysticism. They sought mechanisms, causes, explanations rooted in physics. But beneath the calculations, there was still a hush of unease, because if the existence of two such galaxies was confirmed, then something had to give. Either our understanding of galaxy formation was incomplete, or our model of dark matter itself was flawed. Neither possibility was comforting. Think about what it means for a theory to break. Dark matter had been the invisible thread stitching the cosmos together for decades. Its existence explained the rotation of galaxies, the clustering of matter, the very structure of the universe on the largest scales. To suggest that it might not be essential everywhere was to tug at that thread, and no one knew how much of the cosmic fabric might unravel if it were pulled too far. The presence of DF2 and DF4, side by side, forced a new kind of question. Was this a local anomaly, a peculiarity of the NGC 1052 system, or was it a glimpse of a broader truth? Were these galaxies rare exceptions, or were they windows into a hidden diversity of galactic forms, waiting quietly in the night for us to notice? The tension was not just scientific, but existential. Humanity has always sought patterns, rules that make sense of the stars. But here, the stars were telling us a story that broke the pattern. And the more carefully we listened, the more insistent the story became. Pause, and imagine drifting beyond the Milky Way, crossing the void toward this cluster of faint phantoms. You would pass the giant bulk of NGC 1052, its mass bending space like a heavy stone on a stretched fabric. And there, hovering like mist around a mountain, you would find them, DF2 and DF4. So faint that you could see other galaxies through them, so fragile that they seemed on the edge of dissolution, yet persisting. Not one ghost, but two, haunting the same stretch of sky. It is difficult not to feel a shiver at the thought, because two phantoms together feel less like coincidence, and more like conspiracy, more like a message written in light and distance, waiting for us to understand. And so, astronomers turned their gaze outward, not just at the galaxies themselves, but at the larger structures around them. If DF2 and DF4 were truly stripped of their invisible skeletons, then perhaps the answer lay not within their faint forms, but in the environment that cradled them. Perhaps the secret to their ghostly existence was written in the gravitational embrace of the cosmos that surrounded them. In the vastness of the universe, relationships between galaxies can be as intimate and fraught as relationships between living beings. Galaxies do not drift in isolation. They cluster, they collide, they merge, they tear each other apart. The grand architecture of the cosmos is not static, but dynamic, full of encounters and entanglements. And in the case of DF2 and DF4, their strangeness may not lie entirely within themselves, but in the shadow of their powerful neighbor, the massive elliptical galaxy NGC 1052. NGC 1052 is no delicate wisp. It is a cosmic heavyweight, a sprawling elliptical giant that dwarfs its faint companions. If DF2 and DF4 are fragile lanterns glowing in the dark, NGC 1052 is the roaring furnace beside them, its gravity like a deep well carved into the fabric of space. To understand the mystery of the two ghostly galaxies, astronomers turned their attention to this titan, asking whether its influence might explain what they saw. The theory that emerged was both elegant and unsettling. Perhaps DF2 and DF4 were once ordinary galaxies, born with their own halos of dark matter like all the rest. But as they orbited near NGC 1052, the giant's immense gravity reached into their fragile forms and began to tear them apart. Imagine a giant tugging at a spider's web, pulling loose the invisible strands that give it structure until the web sags and collapses. Or picture two paper lanterns drifting too close to a bonfire, their thin frames warping in the heat until their scaffolding weakens. The idea was that NGC 1052 had stripped DF2 and DF4 of their dark matter, pulling it away in tidal streams, leaving the galaxies naked and skeletal. This explanation, if true, would preserve the overall framework of cosmology. It would mean that dark matter is still everywhere, still essential, but that in rare and extreme cases, a galaxy could be robbed of it by a larger, hungrier neighbor. The ghostly appearance of DF2 and DF4 would then be less a violation of cosmic law and more a testament to the violence of galactic interactions. But even as the theory provided comfort, it also introduced a chilling thought. If galaxies can be stripped of their dark matter, then they are not fixed entities. They are vulnerable, fragile structures whose invisible bones can be broken. We like to think of galaxies as eternal islands, immense and unyielding. Yet here was evidence that they are more like organisms in an ecosystem, subject to stress, predation, and decay. Take a moment to imagine the process. You are drifting through the void, watching DF2 and DF4 orbiting in their quiet path near NGC 1052. Slowly, over millions of years, the gravity of the giant begins to pull. At first, the dark matter halos surrounding the galaxies stretch and deform. Then, like threads pulled from a tapestry, the dark matter streams away into space, unseen but not unfelt. The galaxies grow thinner, lighter, their structures loosening until they are little more than pale clusters of stars floating without skeletons. What remains is a ghost of what once was, a lantern with its frame torn away, a relic of a violent relationship with a massive neighbor. This possibility reframed the mystery. DF2 and DF4 were no longer defying the rules of dark matter, but instead embodying the consequences of galactic interaction. Their strangeness was not a rejection of the invisible scaffolding, but a testament to its fragility. Yet, as with all things in science, the solution raised as many questions as it answered. If NGC 1052 had stripped these galaxies of their dark matter, where had it gone? Could astronomers detect the missing halos stretched into faint streams of unseen matter around the giant? And if such processes were possible, how many other galaxies in the universe might have been similarly stripped, their ghostly remnants waiting to be discovered? The implications rippled outward. The universe may not be as orderly as once imagined. Galaxies may not always follow the neat blueprints that cosmologists had drawn. Instead, they may be fragile players in a cosmic dance, subject to loss, transformation, and violence. And yet, not everyone was satisfied with this explanation. The stripping hypothesis solved some problems, but not all. It still required assumptions, and it relied on interactions that were difficult to prove with certainty. The universe does not show its scars easily. evidence of tidal stripping is faint, often hidden, requiring observations at the very edge of detectability. For some, the idea that DF2 and DF4 had been robbed of their dark matter seemed almost too convenient, a way to preserve the theory rather than challenge it. And so, an even more unsettling thought began to creep into the debate. What if these galaxies had not been stripped at all? What if they had never possessed dark matter to begin with? This possibility was more radical and more terrifying. It suggested that the standard model of galaxy formation, in which dark matter halos are the seeds from which luminous galaxies grow, might not be universal. It suggested that the cosmos has other ways of writing galaxies, ways that do not fit into the neat categories of our current understanding. Two faint phantoms, DF2 and DF4, floating in the shadow of a giant, became symbols of this deeper uncertainty. Were they victims of cosmic theft, their bones stolen by their massive neighbor? Or were they born skeletal, anomalies that point to a hidden truth about the universe? As astronomers debated, the galaxies remained as they were, silent and ghostly, their light drifting across the void. The answers lay not in their whispers, but in the larger structures around them, in the fingerprints of their interactions, in the shadows they cast on our theories. And so the story turns again, from the giant that may have stripped them, to the unsettling possibility that these galaxies were never whole in the first place. From the very beginning of modern cosmology, dark matter has been imagined as the invisible glue holding the universe together. Every galaxy, every cluster, every cosmic filament is thought to be bound by its unseen presence. Without it, the fragile webs of stars and gas would drift apart, unable to withstand the relentless spin of their own motion. It is the scaffolding, the frame, the silent structure beneath the luminous face of the cosmos. And yet, there lingers a possibility, so strange, so unsettling, that not all galaxies require this glue. Some theories whisper of galaxies born without dark matter, defying the universal rule, living their quiet lives without the hidden skeleton that defines the rest. If true, this would be nothing short of revolutionary. It would mean that the cosmos has more than one recipe for creation, that galaxies are not bound to a single blueprint, but may emerge in ways we never imagined. To grasp how strange this idea truly is, imagine a spider trying to spin a web in midair. Normally, the spider relies on an anchor, branches, walls, corners to support its delicate threads. Dark matter serves as this anchor for galaxies, a foundation into which stars weave themselves. Without it, the web would fall apart, the silk unraveling with nothing to cling to. And yet, in this radical vision, stars have somehow gathered into galaxies without any invisible anchor, clustering against all odds into coherent shapes. It is as though the spider has succeeded in weaving a web suspended only by air. Astronomers and theorists have long debated whether such galaxies could exist. In simulations of the early universe, dark matter halos form first, dense seeds that draw in gas and ignite the birth of stars. Without halos, the gas alone should be too thin, too dispersed, to ever coalesce into galaxies. Stars should form sparsely, isolated like candles in the dark, never clustering into something as grand as a galaxy. And yet, DF2 and DF4 seem to sit before us as counterexamples, quiet whispers that perhaps we do not yet understand the full range of cosmic creativity. Consider the implications of this. If galaxies can form without dark matter, then the neat story of cosmic evolution is incomplete. Dark matter may still dominate the universe, but it may not be as universal as we once thought. It may be one path among many, not the single foundation we assumed. The architecture of the cosmos might be far more diverse, full of unexpected exceptions. This possibility unsettles not just astronomy, but philosophy. Humanity has long sought simple, elegant rules beneath the complexity of nature. We crave universality, a principle that applies everywhere without exception. But what if the universe resists such simplicity? What if its beauty lies not in uniform laws, but in a chaotic variety, where even the deepest rules are bent, twisted, and sometimes broken? The thought is dizzying. For decades, dark matter has been treated as inevitable, unquestionable, a cornerstone of modern physics. To imagine galaxies thriving without it is to chip away at that cornerstone, leaving cracks in the very foundations of cosmology. And through those cracks, unsettling questions emerge. If galaxies can exist without dark matter, what does that say about the nature of dark matter itself? Perhaps it is not a universal skeleton, but a contingent one, present in most galaxies, but absent in some. Perhaps it is not the fundamental ingredient we believed, but an emergent property shaped by context and environment. Or perhaps we are not looking at dark matter at all, but at something deeper, some hidden aspect of gravity, or some new law of physics, masquerading as a missing mass. Take a moment here and imagine drifting through one of these hypothetical galaxies. Without the heavy halo of dark matter, the stars are more loosely bound, the gravity weaker. You would feel the difference, not as chaos, but as lightness, a delicate openness, as though the galaxy were breathing more slowly. Its stars would still shine, still orbit, but their orbits would be gentler, their bonds more fragile. Such a galaxy would feel airy, ethereal, like a soap bubble floating in the void. Fragile, yes, but also beautiful. The very existence of such fragility would suggest that the cosmos tolerates impermanence, that not all structures are built to last. Some galaxies may endure for billions of years, anchored by their dark matter halos. Others may be fleeting, their delicate arrangements unraveling over cosmic time, vanishing back into the void from which they came. To accept galaxies without dark matter is to accept a universe where transience is as real as permanence. For scientists, the challenge is immense. If dark matter is not universal, then every observation becomes a new question mark. Which galaxies have halos and which do not? By what mechanism do some acquire them while others are left bare? Is there a threshold, a cosmic condition that determines whether a galaxy is born with dark matter or without? For philosophers, the challenge is deeper still. A universe without universality, a cosmos where exceptions undermine the rule, demands a different way of thinking. It asks us to embrace ambiguity, to accept that the universe may not be governed by a single elegant equation, but by a messy diversity of processes. The cosmos becomes less like a machine and more like an ecosystem, full of variation, adaptation, and surprise. And yet, there is a certain beauty in this vision. To imagine galaxies born without dark matter is to expand our sense of possibility, to recognize that the universe may be even more inventive than we dreamed. It is to marvel at the resilience of stars, capable of clustering even without the invisible glue we assumed was essential. Still, the question lingers. If dark matter is not universal, then what exactly is it? A fundamental particle waiting to be discovered in laboratories deep underground? A property of gravity itself, revealed only at cosmic scales? Or something stranger still, something we have not yet imagined? The phantoms of DF2 and DF4 do not answer these questions. They only deepen them. They stand as enigmas, hints of a universe more complicated than we hoped, more mysterious than we feared. And so the story turns once again from the possibility of galaxies without dark matter to the deeper question. If dark matter is not universal, then what else might it be? For half a century, dark matter has reigned as the most elegant explanation for the missing mass of the cosmos. It is the unseen partner in every cosmic dance, the silent actor on every galactic stage, invoked to explain the motions we cannot otherwise understand. Without it, the story of galaxies appears broken. And yet, in spite of decades of searching, in spite of an entire generation of scientists devoting their lives to hunting this phantom, dark matter has never been seen. That is perhaps the most unsettling truth of all. Imagine the scale of effort. In mountains hollowed into laboratories, detectors have been buried under kilometers of rock, shielded from cosmic rays and earthly noise, waiting patiently for the faintest whisper of interaction. Tanks filled with liquid xenon, crystal chambers cooled to near absolute zero, intricate arrays of sensors capable of detecting a single flicker of light, all designed to catch the moment when a dark matter particle brushes against ordinary matter. Billions of dollars have gone into these experiments, spanning continents and decades. And yet, silence. No flash, no signal, no definitive trace, just a profound, unsettling emptiness. Like listening for a voice in the dark and hearing nothing, over and over again. The silence grows heavier with each passing year. At first, physicists expected discovery was just around the corner. Surely a particle so influential, so dominant, could not hide forever. But as experiment after experiment came up empty, optimism dimmed. Perhaps the particles were too light or too heavy, or interacted too weakly. New detectors were built, larger and more sensitive. Each time, the silence deepened. Even the grand accelerators, the mighty colliders smashing particles together at near-light speeds, have searched for hints of new physics that could explain dark matter. But the results remain stubbornly ordinary, revealing nothing but the known, the familiar, as if the universe refuses to yield its secret. This is where the galaxies without dark matter, like DF2 and DF4, begin to whisper louder. Perhaps, they suggest, there is nothing there to find. Perhaps the silence is not a failure of technology, but a clue. Perhaps the invisible glue is not real at all. Take a moment to let that idea settle in. A half-century of theory, countless careers, billions of dollars, and a cornerstone of cosmology itself. What if all of it rests on an illusion? What if dark matter, this unseen scaffolding of the cosmos, simply does not exist? This thought is terrifying, yet also liberating. Terrifying, because it rips away the comfort of a well-ordered cosmos, exposing cracks in the very story we tell about the universe. Liberating, because it invites imagination, opening doors to alternatives we might never have considered. The galaxies without dark matter could be more than anomalies. They could be evidence. Evidence that the universe has been hinting at something deeper all along, and that our insistence on dark matter may have blinded us to other truths. Think of astronomy in the centuries before dark matter was imagined. Astronomers once explained the heavens using epicycles, small circles within circles, to account for the strange motions of planets. The system was elegant, predictive, and widely accepted. Yet it was fundamentally wrong. The motions were not caused by hidden circles, but by gravity itself, working in ways no one yet understood. Could dark matter be the epicycle of our age? A mathematical patch, useful for predictions, but masking a deeper reality. The question unsettles more than physics. It unsettles the way we think about knowledge itself. How many of our deepest assumptions are scaffolds, fragile and temporary, destined to be replaced? How many truths are illusions we cling to because they fit neatly into our frameworks? Pause, and imagine how it feels to be a scientist facing this silence. To dedicate years of one's life to the search for something invisible, to lower detectors into the earth, to analyze endless streams of data, waiting for the faintest sign, and to find nothing. The human element is heavy here. Frustration, doubt, fatigue. Some cling to hope, refining models, suggesting subtler particles, more exotic interactions. Others begin to wonder whether they are chasing shadows. Yet the beauty of science lies in its willingness to doubt itself, to admit when cracks appear, when foundations shake, when what once seemed solid begins to crumble. In that vulnerability lies progress. And so we arrive at the unsettling possibility. Galaxies like DF2 and DF4 are not mistakes. They are not illusions of distance or artifacts of measurement. They are cosmic messages pointing to a truth we have resisted. They are the whisper that perhaps there is no dark matter at all. If that is true, then we must ask, what holds galaxies together? If not invisible glue, then what? Is gravity itself misunderstood, weaker or stronger in ways we cannot yet measure? Are we staring at the wrong equations, clinging to Newton and Einstein when the cosmos is begging us to look deeper? Or is there another hidden ingredient, stranger than dark matter, waiting to be discovered, not in silence, but in a revolution of thought? The cracks in the dark matter theory are not just scientific cracks. They are philosophical ones. They remind us that the universe is not obliged to fit our models, that silence can be as instructive as noise, that absence itself can be a form of presence. It is humbling to stand in this silence, to imagine that what we thought of as universal may be nothing but a shadow cast by our own misunderstanding. And yet, this is the essence of exploration. Not certainty, but wonder. Not answers, but questions. The galaxies without dark matter are cracks in the story, yes. But through those cracks, light pours in, and the light asks us the next question. If not dark matter, then what is the true force binding the stars? There is a certain audacity in questioning gravity. For centuries, it has been the most familiar of forces, the one that presses feet into the ground, pulls apples from trees, and tethers the moon to its orbit. Newton gave it mathematical form. Einstein gave it curvature and elegance, and humanity has treated it ever since as one of the most reliable truths of existence. To say that gravity itself might be wrong, or at least incomplete, is to step into dangerous territory. And yet, as the silence of dark matter searches grows heavier, some scientists have dared to walk this path. The logic is simple in its boldness. If the invisible glue cannot be found, perhaps there is no glue at all. Perhaps the problem lies not in the absence of matter, but in the way we understand motion. Just as rivers do not bend because invisible hands push the water, but because the laws of flow behave differently in broad valleys than in narrow creeks, so too might the cosmos follow rules of gravity that change with scale. This was the radical vision behind a theory called MUND, or modified Newtonian dynamics. Proposed in the early 1980s by physicist Mordechai Milgram, MUND suggested that the equations of Newton, though accurate in our solar system, might fail when applied to the vast scales of galaxies. In other words, gravity might be stronger, or at least act differently, when accelerations are extremely weak, such as in the outer edges of galaxies. At first, the idea sounded absurd. Gravity was already well tested, from the fall of objects on Earth to the orbits of planets, from spacecraft trajectories to the bending of light near stars. Why would it suddenly change its behavior in the faint outskirts of galaxies? But Milgram's equations worked. They predicted galactic rotation curves, the speeds at which stars orbit their centers, without invoking dark matter. Where invisible halos were once required, MUND provided an adjustment to the law of gravity, and the stars fell into place. It was a deeply seductive solution. For those weary of chasing unseen particles, MUND offered a clean escape. No invisible scaffolding, no ghostly matter, just a refinement of the equations we already know. A whisper that perhaps the cosmos is not filled with hidden mass, but with subtler mathematics. And yet, the story takes a paradoxical twist. For while galaxies like DF2 and DF4 seem to challenge the existence of dark matter, they also challenge MUND itself. Because if MUND were true, no galaxy could ever look as though it had no dark matter. MUND predicts that gravity changes universally, applying its new rules everywhere, regardless of how much mass is visible. And yet, DF2 behaves exactly as Newton's original equations would predict. Its stars orbit with a speed perfectly consistent with their visible matter, as though MUND had no effect at all. This is perhaps the most haunting irony in the mystery of galaxies without dark matter. They not only weaken the case for invisible halos, they also undermine the elegant alternative. In one stroke, they complicate both paths, leaving scientists stranded between two competing frameworks, both cracked, both incomplete. Take a moment to imagine the philosophical weight of this. For decades, the great debate has been framed as a duel between dark matter and modified gravity. On one side, the search for particles, hidden but real, awaiting discovery. On the other, the daring proposal that gravity itself bends differently than we thought. DF2, in its ghostly stillness, seems to mock both sides. It behaves as though the universe is playing a trick, withholding the truth, forcing us to look deeper still. This raises unsettling questions about the nature of scientific progress itself. How do we proceed when both explanations falter? Do we double down on experiments, hoping the silence of dark matter will one day break? Do we refine MUND, twisting equations further to preserve its usefulness? Or do we dare to admit that both might be wrong, and that something stranger still is at work? Imagine drifting across the galaxy DF2, feeling the pull of its stars. There is no hidden weight, no extra tug. The orbits are delicate, precise, matching perfectly the visible light. It is as though the universe, just for this galaxy, decided to strip away the veil, to show us what lies beneath both dark matter and modified gravity. And yet, the meaning of what we are shown remains unclear. The impact of this is not just scientific, but philosophical. It reminds us that our models are maps, not territories. Newton's laws mapped the solar system well enough to send ships to the moon. Einstein's relativity mapped space-time with breathtaking accuracy, predicting black holes and gravitational waves. MUND maps certain galactic behaviors uncannily well. Dark matter maps large-scale structure, explaining the cosmic web and the growth of galaxies. And yet, perhaps none of these maps is the final one. Perhaps the universe is a land so vast and strange that no single chart will ever capture it. This realization carries both humility and beauty. Humility, because it shows how much we do not know, how often our confidence in universal laws gives way to exceptions. Beauty, because it means the cosmos is always larger than our understanding, always holding secrets just out of reach, always inviting us onward. The paradox of DF2 and its kin forces us into this humility. They show us that our two great contenders, dark matter and modified gravity, may both be incomplete. They press us to imagine a third path, one we cannot yet see, one that may rewrite not only galaxies but the very nature of physical law. So where does this leave us? Suspended between explanations, listening to the silence of detectors, staring at ghostly galaxies, and realizing that our theories may not be enough. Perhaps dark matter is real, but more elusive than we ever dreamed. Perhaps gravity is stranger still, not merely modified, but transformed at cosmic scales. Or perhaps the truth lies beyond either, waiting in a place our current imagination cannot yet reach. The galaxy DF2, in its quiet defiance, points us toward this unknown. It asks us to let go of certainty, to sit in the discomfort of paradox, to wait patiently for the next clue. Because whether dark matter exists or not, whether gravity bends differently or not, the cosmos will not yield its secrets easily. It will make us earn them through doubt, through wonder, through persistence. And so the story flows on. If not dark matter and not modified gravity, then what holds galaxies together? What invisible hand or unknown law prevents them from flying apart into nothingness? The universe, vast as it is not empty. Beyond the glowing galaxies and scattered stars, there lies a hidden structure, a great architecture woven through the dark. It is not a random scatter, but an intricate tapestry, as though the cosmos itself were threaded by invisible filaments. Astronomers call this structure the cosmic web. To see it in the mind's eye, imagine strings of pearls laid out on nearly transparent threads, delicate yet expansive. Each pearl is a galaxy, luminous and fragile. Each thread is thought to be made of dark matter, unseen but essential, guiding the galaxies into their positions. Where the threads cross, clusters of galaxies form, heavy nodes in the web. Between these intersections lie the great cosmic voids, vast expanses where the pearls are absent and the silence is nearly total. For decades, this picture has been the prevailing one. Simulations of the early universe, seeded with dark matter, grow into patterns that match the web we observe in the night sky. Without dark matter, the filaments fray and dissolve, unable to weave galaxies into such striking structures. The cosmic web is often described as the fingerprint of dark matter itself, a visible echo of the invisible. But then come galaxies like DF2 and DF4, whispering of an unsettling contradiction. If galaxies are strung along invisible filaments, how can one exist without the thread? How can a pearl sit in space without a string, without an anchor, suspended in the void like a bead that has somehow slipped loose? This is where the mystery deepens. For galaxies without dark matter are not just anomalies, potential breaks in the cosmic web. They are torn threads, snapped connections, loose jewels drifting apart from the necklace. If the web is truly universal, its strands should not break so easily. And yet, here we are, staring at faint galaxies that suggest otherwise. Pause for a moment and picture yourself drifting through such a place. Around you stretches the faint glow of stars, but no thread of dark matter ties them together. No invisible hand connects them to the larger web. It feels lonely, fragile, as though you have stepped into a corner of the universe where the pattern itself has failed, where the cosmic loom has dropped a stitch. The emptiness presses in, and the galaxy feels like a ghost, a survivor of something violent, or a mistake in the weave. Astronomers cannot help but wonder, are galaxies without dark matter signs of broken threads in the web? Could they be scars left behind by cosmic accidents, the aftermath of collisions, or tidal forces that strip them bare? Or are they deeper mysteries still, evidence that the web is not as universal as we believe? The implications are profound. If the cosmic web is not unbreakable, then the universe may be more dynamic, more violent than we imagined. Galaxies may not simply drift along filaments in quiet obedience. They may be torn away, cut loose, reshaped by interactions too fierce for invisible scaffolding to survive. And if that is possible, then our image of the cosmic web must change. It is no longer the eternal skeleton of the cosmos, but a living fabric, vulnerable to rupture and decay. The very thought unsettles the imagination. The cosmic web has long been portrayed as a kind of perfection, a vast and orderly system underlying the chaos of galaxies. To picture its threads snapping is to introduce fragility into what once seemed eternal. It is to imagine that even the universe's deepest structures are not immune to violence, that even the hidden bones of creation can fracture. This vision resonates with human experience in a strange way. Just as the threads of memory or connection in a human life can snap, leaving one adrift, so too might galaxies be left stranded by the breaking of their cosmic threads. In both cases, the result is a haunting loneliness, a sense of being cut off from the larger pattern. Perhaps that is why galaxies without dark matter feel so ghostly. They are metaphors for disconnection on the grandest possible scale. And yet, the existence of such galaxies also carries a paradoxical beauty. If they are indeed beads without strings, then they reveal that the universe tolerates imperfection, that its tapestry is not flawless, but full of gaps and irregularities. In those imperfections, there may be lessons. The cosmos is not a machine producing uniform outcomes. It is an artist painting with broad strokes, allowing for chance, for rupture, for variance. For scientists, the challenge is to determine whether these torn threads are real, and if so, how they were created. Were DF2 and DF4 once ordinary galaxies, stripped of their halos by the gravitational pull of NGC 1052, the giant elliptical neighbor looming nearby? Were they shaken loose by tidal forces, like pearls knocked from their necklace by an invisible hand? Or are they fundamentally different? Galaxies that never had threads to begin with, woven not by the cosmic web, but by some other process entirely? For philosophers, the challenge is to accept that even the deepest patterns may be incomplete. The cosmic web may still be the dominant structure of the universe, but exceptions remind us that no rule is absolute. The presence of galaxies without dark matter suggests that the universe holds surprises even in its foundations, that what we call universal may in truth be local, contingent, or fragile. Take another moment and let this image linger. The universe as a tapestry, vast and glittering, yet not flawless. Here and there, a thread is missing, a connection broken, a pearl gone astray. The beauty of the whole is not diminished by these gaps. In fact, the gaps add to its mystery, inviting us to look closer, to wonder what happened, to search for the forces that shaped them. And so, we return to the question at the heart of this segment. Are galaxies like DF2 and DF4 beads that slipped loose, torn from their threads by cosmic violence? Are they echoes of past events, scars left behind by encounters too fierce for even dark matter to endure? The thought lingers, unsettling and dark. Because if galaxies can be torn from their threads, then perhaps the universe is not the serene and orderly place we once imagined. Perhaps it is a place of violence and fracture, where even the deepest structures can break. Which leads to an even darker question. Could these ghostly galaxies be echoes of violent past events, remnants of a cosmic trauma written across the stars themselves? When most people imagine the night sky, they picture stillness. Stars fixed in their constellations, galaxies drifting serenely, light frozen across unimaginable distances. But in truth, the universe is anything but calm. It is a place of constant motion, of collisions and struggles, of destruction as much as creation. Galaxies do not simply float in isolation. They hunt, they consume, they collide. In the silent theater of the cosmos, the actors are wolves, not lambs. Astronomers call this process galactic cannibalism. It sounds violent, and it is. Galaxies grow not only by forming new stars, but by devouring smaller companions, tearing them apart, and adding their matter to their own. Sometimes the merger is graceful, a slow dance where stars swirl and settle into a new arrangement. Other times it is brutal, a head-on collision where tidal forces rip stars free, scattering them into space like sparks from a fire. Picture it in your mind. Two great spirals drifting closer, their arms stretching toward one another like claws. At first they are beautiful, luminous swirls entwining in an elegant embrace. But then gravity tightens its grip. The spirals twist and break. Stars are flung outward. Clouds of gas collapse into bursts of new stars. Dark matter halos, once invisible shields, overlap and distort, torn apart by the violence of the encounter. What was once two galaxies becomes one, but not without scars. Now imagine the smaller companions in this cosmic feast. Dwarfs and satellites, fragile lanterns of stars, caught in the gravitational grip of giants. They are stripped bare, their gas siphoned away, their stars stolen, their dark matter halos shredded. What remains is often a husk, a faint remnant, drifting on the outskirts like a survivor of some ancient war. Could this be the story of DF2 and DF4? Could these faint, ghostly galaxies be battle scars, survivors of cosmic violence inflicted by their massive neighbor, NGC 1052? The idea is hauntingly plausible. Both DF2 and DF4 lie close to this elliptical giant, a galaxy far more massive than they are, its gravity strong enough to tear at their fragile frames. If the two faint galaxies once possessed dark matter halos, those halos may have been stripped away in the struggle, their invisible bones shattered and lost. What remains would be stars only, thin and fragile, but still coherent enough to glow faintly against the void. This possibility reframes the mystery. If DF2 and DF4 are not primordial exceptions, not galaxies born without dark matter, but survivors of violence, then they are less like puzzles and more like scars. Their existence would not disprove dark matter, but illustrate its fragility. It would show that even the invisible skeleton of galaxies is not unbreakable, but vulnerable to the jaws of giants. Take a moment to reflect on that fragility. The very thing that scientists have imagined as universal and immutable, the dark matter halo, may itself be impermanent. It can be stretched, distorted, even destroyed. Just as bones can be shattered in battle, so too can galaxies be broken in the silent wars of the cosmos. The metaphor is striking. In wolves fighting over prey, flesh is torn, bones are cracked, and only fragments remain. In galactic cannibalism, stars scatter, gas ignites, and dark matter is shredded. What we observe in DF2 and DF4 may be nothing more than the cosmic equivalent of bones gnawed clean, the remnants of a feast long finished. And yet, something about this explanation leaves a lingering unease. If DF2 and DF4 are survivors of such violence, why do they look so calm? Why do their stars orbit serenely, without the chaos one might expect from trauma? They are ghostly, yes, but also strangely stable, their structures intact, their forms almost delicate. It is as though they have endured unimaginable violence, and yet emerged tranquil, even peaceful. This paradox deepens the mystery. Survivors of galactic cannibalism are often messy, irregular, scarred by the violence that shaped them. But DF2 and DF4 are not. They are faint, but coherent, transparent, but ordered. Their stability whispers that perhaps the violence they endured was not as destructive as it should have been, or that something else entirely is at work. Philosophically, the idea of galactic cannibalism resonates with human history. Civilizations rise and fall through conflict. Empires devour one another, leaving behind ruins and survivors, scars etched into the landscape. And yet, from the ruins, something new always emerges. The survivors carry stories of what once was. In this way, galaxies like DF2 and DF4 are cosmic storytellers. They carry within their faint light the memory of violence, scars written not in ruins, but in absence, the absence of dark matter, the absence of invisible bones. There is a strange beauty in this. To see these galaxies is to glimpse survival itself, fragile yet persistent. They may be the remnants of violence, but they are also the proof that something endures, that even after the invisible skeleton is stripped away, the stars can still cling together, still shine, still tell their quiet story to the void. For scientists, these galaxies offer a rare opportunity. They may be laboratories for studying how galaxies evolve through conflict, how dark matter behaves under extreme conditions, how fragile structures survive trauma. By studying their stability, we may learn not only about dark matter, but about resilience itself, how galaxies adapt, how stars reorganize, how the cosmos preserves coherence even in the face of violence. For dreamers, they are symbols of endurance. They remind us that scars do not erase identity, that even the most fragile structures can persist after trauma. They are, in their way, emblems of survival on the grandest scale. And yet, the nagging unease remains. If these galaxies are truly survivors of cannibalism, why do they seem so serene? Why are they not twisted wrecks, but tranquil ghosts? What holds them together in such delicate balance when by all rights they should have fallen apart? The question lingers like a shadow at the edge of the mystery. And so the story flows forward, deeper into the unknown. Because if galactic cannibalism explains part of the tale, it does not explain it all. There is still something uncanny about these galaxies, something too neat, too stable, too quietly defiant. Which leads to the next puzzle, the next unsettling thought. If DF2 and DF4 are scars of violence, then why do they remain so serene, so ordered, as though untouched by the chaos that stripped them bare? In the vast darkness, DF2 and DF4 drift like whispers. They are not wreckage scattered across the sky, not chaotic splinters of a galactic battlefield, but quiet, coherent, fragile structures of light. They appear almost serene, as though untouched by the violence that might have stripped them of their hidden bones. It is this serenity, this strange stillness, that unsettles astronomers most. If their dark matter was stolen, the expectation is simple: chaos. When galaxies are stripped of their invisible halos, tidal forces should distort them, stretching them into ragged shapes, tearing their stars into elongated streams. Survivors of galactic cannibalism are rarely graceful. They wobble, they warp, they twist into strange and jagged forms. But DF2 and DF4 do not behave this way. They are not ragged, not broken. They are ghostly mirrors of ordinary galaxies, dim and transparent, but strangely well-ordered. Their stars drift quietly, their structures hold together, and they float in the void like lanterns carved from mist. It is almost as if they are witnesses rather than victims. Silent observers of forces we barely comprehend, existing not as scars but as enigmatic testimonies. Their calmness is not natural. It is almost theatrical, like characters frozen in a tableau, waiting to be understood. Take a moment to imagine them. Two faint smudges of light in the telescope's gaze, delicate and ethereal. Each star is visible. Because the galaxies are so sparse, their starlight not blended into a blur, but scattered like dust motes in a beam of sunlight. They are transparent, almost see-through, like cosmic apparitions. And yet, the stars remain gravitationally bound, moving in quiet harmony. It is not the harmony of strength, but of something inexplicably gentle, a balance that should not exist. Scientists wrestle with this paradox. If DF2 and DF4 are stripped, where is the evidence of distortion? If they are survivors of violence, why do they look so unscarred? Their ghostly beauty whispers that perhaps our categories are insufficient, that perhaps we are trying to explain their existence with tools too blunt, with assumptions too rigid. They seem to sit at the edge of comprehension, reminding us that the universe does not owe us simplicity. One could say that DF2 and DF4 are galaxies that refuse to scream. If they endured trauma, they endured it in silence. If they were broken, their brokenness is invisible to us. They float as if nothing happened, even though everything about them screams that something impossible has occurred. Philosophically, they are haunting. They remind us of the limits of our perception, of how easily we assume chaos must look chaotic. Scars must look jagged, survival must leave obvious traces. But perhaps the universe does not play by our aesthetic rules. Perhaps it is capable of producing survivors who do not look like survivors, scars that appear like glass, fragility that endures without explanation. Think of a painting left in the rain. One expects it to run, to blur, to collapse into chaos. But imagine instead if it grew more delicate, more translucent, the colors fading into something ghostly and ethereal. That is what DF2 and DF4 feel like. Paintings touched by storms, but transformed into quiet works of art rather than wrecks. This is why they feel so much like silent witnesses. They do not shout their story, they whisper it. They sit quietly in the void, not demanding attention, but offering it to those who look closely enough. They embody a contradiction, too calm for their supposed history, too fragile to endure without help, too strange to fit into our models, yet too coherent to dismiss as illusion. For astronomers, this silence is more terrifying than chaos. Chaos can be explained by violence, by collision, by the normal brutality of cosmic evolution. But calmness where there should be chaos, order where there should be ruin, that suggests rules we do not yet know. It suggests we are staring at an equation without variables, a riddle missing its most important clue. What if DF2 and DF4 are not scars at all? What if they were never whole in the way we imagine? What if their tranquility is not the residue of survival, but the essence of their being? In that case, they would not be victims of a giant neighbor, but galaxies born to be this way. Galaxies that testify to laws we have not yet written. Their calm would not be deceptive. It would be fundamental. Take a breath and let that thought settle. Two galaxies, floating quietly, defying violence, embodying serenity. Not mistakes, not ruins, but possibilities. Possibilities that hint at universes within the universe, rules beneath the rules, structures beyond the scaffolding we assume to be universal. In their silence, DF2 and DF4 echo into something larger. They become symbols, not just of dark matter's mystery, but of the limits of human comprehension. They stand as gentle reminders that the universe is not obligated to match our expectations. And sometimes, what it shows us is not thunder, not lightning, not destruction, but something quieter, something that unsettles precisely because it is so calm. The poet in us might say they are like monks of the cosmos, meditating in stillness, bearing witness to truths they cannot explain but only embody. The scientist might say they are data points, challenging our models, hinting at unseen variables. The dreamer might say they are ghosts, lanterns of forgotten laws, fragile reminders that the universe is not yet finished telling us its story. And so we return to the central unease. Their calmness is not the calmness of order, nor the calmness of ruin, but a new kind of calm, one we do not yet know how to name. They sit between categories, defying them all, offering themselves as puzzles without solutions. The silence of DF2 is not empty. It is full of questions, full of echoes, full of mysteries waiting to be born. Their tranquil existence points outward into something larger, something even stranger than two galaxies without dark matter. For their calm is not the end of the story, but the beginning of a much darker, deeper question. And this silence, this stillness that should not be, echoes into the vastness of a much larger mystery. The faint light of DF2 and DF4 lingers in the imagination, like candle flames in a cavern too vast to comprehend. They are not loud. They do not shout their mystery into the void. Instead, they whisper. And their whisper is dangerous, because it hints at something more radical than missing dark matter. It hints at the possibility that the universe itself is not what we think it is. For more than a century, astronomy has built its vision of the cosmos on a scaffold of assumptions. One of those assumptions is that dark matter is everywhere, that every galaxy wears an invisible skeleton of it, that every star we see is glued into place by halos of unseen particles. The story has been neat, elegant, even comforting. But galaxies like DF2 and DF4 disturb that comfort. Their faint, ghostly presence pushes against the scaffolding, bending the story until cracks appear. What if dark matter is not one thing at all? What if it is not a single, invisible particle drifting silently through the void, but a tapestry of forces and phenomena, some of which we have not even begun to imagine? Perhaps the universe is not simple enough to be explained by a single invisible glue. Perhaps it hides multiple layers of hidden matter, or even hidden rules, weaving together a structure more elaborate than any model we can conceive. Imagine standing in a forest at night with only a lantern. You see the trunks closest to you, you sense the branches overhead, but the deeper patterns, the interlocking roots, the full expanse of the ecosystem remain hidden. You can map what little you see, and you can guess at the rest, but your lantern will never reveal the whole forest. DF2 and DF4 feel like sudden glimpses of something vast, like a root emerging where it should not be, or a path that bends in directions you never expected. Perhaps dark matter itself is not the question, but gravity's partner in disguise. Perhaps what we call dark matter is really the shadow of laws we have not yet uncovered, forces that bend and twist only at cosmic scales, forces that are as far beyond Newton and Einstein as their laws were beyond Aristotle's. The mind bends when it tries to grasp such possibilities. Gravity is the oldest of the known forces, the one we thought we understood best, the one that guides apples to the ground and planets around stars. Yet again and again, it refuses to be fully tamed. Perhaps it holds secrets that mock our equations, and perhaps the cosmos is even stranger still. What if dark matter is not matter at all, but geometry? What if it is the shape of space itself, curving in ways invisible to light, carving unseen valleys where stars and galaxies fall and settle? In such a view, DF2 and DF4 may be exceptions only because our perspective is incomplete. They may obey laws of a larger geometry that we have not yet traced, just as ancient sailors once obeyed the winds without ever knowing the true shape of the earth. These questions are terrifying and beautiful because they destabilize everything we thought we knew. For decades, dark matter has been the invisible foundation of cosmology. And yet, here are galaxies that seem to exist without it, like cracks in the foundation, or perhaps like windows opening onto another layer of reality. Each time astronomers measure, each time they refine the numbers, the whisper grows louder. You don't know me. Not yet. Take a moment to feel the weight of that whisper. We are creatures who long for certainty, who draw lines on maps, who carve rules into stone. But the universe does not bend to our need for neatness. It remains slippery, evasive, filled with shadows that shift when we shine our lights upon them. DF2 and DF4 are not just galaxies. They are reminders that reality is larger than imagination, that truth is not a destination, but a horizon forever receding as we approach. Philosophers have always warned of this. From the ancients who believed in crystalline spheres, to the medieval dreamers who pictured angels turning the heavens, to the modern physicists who believed that Newton's clockwork had solved the cosmos forever. Each time, the story was rewritten. Each time, reality revealed itself to be stranger, more complex, more resistant to final answers. DF2 and DF4 belong to that tradition of disruption. They are not errors. They are milestones, signposts pointing toward a road we have not yet traveled. Perhaps in a century, students will look back and smile at our confusion. They will know whether dark matter was real or whether it was only a shadow cast by some deeper law. They will see in DF2 and DF4 not riddles, but evidence, data that shaped the revolutions of their time. Just as we look back at Galileo's moons or Hubble's galaxies, so too will future minds look back at these ghostly smudges and see them not as puzzles, but as turning points. And yet, even in imagining that future, there is a kind of humility we must carry. Because the truth may always be stranger than the models we build. The cosmos may always be one step ahead, whispering mysteries just beyond the reach of our lantern light. We must accept that some questions will linger unanswered, perhaps for generations, perhaps forever. This is what makes the silent testimony of DF2 and DF4 so haunting. They are not loud disruptions, not spectacular explosions, but gentle contradictions. They are quiet galaxies, drifting calmly, patiently, carrying secrets in their transparent bones. And in their calmness, they remind us of our limits. They remind us that the universe is not a book we have already read, but a manuscript still being written, filled with pages yet to be turned. So what if the universe is different than we think? What if dark matter is not a single answer, but many? What if gravity itself is incomplete? What if the cosmos is woven with laws that twist and bend beyond human intuition, laws we can only glimpse through exceptions like these? These are not comfortable questions, but they are necessary ones. Because each whisper from galaxies like DF2 says the same thing. You don't know me. Not yet. And that whisper is both a warning and an invitation. A warning that our certainty is fragile, that our models are provisional, that the universe does not owe us simplicity, but also an invitation to wonder, to imagine, to seek, to follow the faint light of ghost galaxies into the deeper darkness, trusting that mystery itself is part of the journey. Which leaves us with one final question, the one that ties all of this together. For if these galaxies are lanterns of mystery, if they are phantoms of a universe we barely grasp, then what do they ultimately teach us? In the quiet expanse of the night sky, where light travels for millions of years only to end its journey in the glass of a telescope, there are messages written in silence. DF2 and DF4 are two such messages, faint and fragile, yet profound. They are not merely anomalies, not curiosities to be filed away in the margins of astrophysics. They are messengers. Messengers from a cosmos that seems to say, you have only just begun to understand me. For centuries, humanity has chipped away at the darkness. With every new instrument, from polished lenses to orbiting telescopes, we have sought to pierce the veil. And in many ways, we have succeeded. We have mapped galaxies by the millions, traced the echoes of the Big Bang, and measured the expansion of the universe itself. We have written equations that describe the dance of planets and the life cycles of stars. And yet, for all this progress, the faint glow of DF2 and DF4 reminds us that knowledge is not the same as understanding. Because here is the truth. A galaxy with no dark matter should not exist. It breaks the very rules upon which modern cosmology rests. Galaxies are supposed to be built upon invisible halos, their stars clinging together because of matter we cannot see. Without it, they should unravel, like sand slipping through open fingers. And yet, DF2 and DF4 drift quietly, serenely, as though mocking our assumptions. Their very existence is both beautiful and terrifying, because it proves that the universe is capable of things beyond our imagination. There is something deeply humbling in this realization. To think that after all our centuries of study, after sending probes to the edges of the solar system and building machines that smash particles at near-light speeds, the universe still has the power to surprise us. It is as if reality itself takes pleasure in reminding us of our limits. For every answer we carve out of the void, 10 new questions emerge, each darker, each stranger, each whispering, "You are not finished." Not yet. Perhaps this is why anomalies unsettle us so much. They are not just puzzles, they are intrusions. They creep into the neat order we have constructed, scattering our tidy assumptions like wind through dry leaves. DF2 and DF4 are not terrifying because of what they are, but because of what they imply. If galaxies without dark matter can exist, even in rare cases, then the foundations of cosmology are incomplete. And if the foundations are incomplete, then the structures we have built upon them may need to be rebuilt. Yet there is beauty in this terror, the beauty of being alive in a universe that refuses to be fully known. The beauty of limits that stretch our imagination further than comfort would allow. We often think of science as a path toward certainty, a way to nail down truth. But perhaps the real gift of science is that it keeps truth alive, vibrant, unfinished. Every discovery like DF2 and DF4 is not a dead end but an opening, a doorway into deeper wonder. Think of them again, those faint galaxies. Transparent, delicate, drifting like smoke across the cosmic sea. They are not grand like the spirals of Andromeda, not dazzling like star-forming nebulae. They are easy to overlook, and yet they may be more revolutionary than all the brilliant swirls we celebrate. They are quiet reminders that the cosmos is not only about spectacle. Sometimes its greatest lessons are whispered in the faintest light. And here, perhaps, lies the most terrifying mystery of all. Not what we don't understand, but how much we still cannot. We may never truly grasp the whole picture. We may build better telescopes, invent sharper theories, push the boundaries of physics itself, and yet the horizon will always move farther away. DF2 and DF4 are not just challenges to our models, they are reflections of our place in the universe. They remind us that we are still children staring into the dark, still learning the first words of a language far older than us. This realization can be unsettling, but it can also be freeing. If the universe is stranger than we can imagine, then wonder is inexhaustible. There will always be more to learn, more to question, more to feel awe about. A galaxy with no dark matter should not exist, and yet it does. That contradiction is not the end of the story, but the beginning of countless new stories, each leading us deeper into the infinite. It is easy to think of fear as the opposite of beauty, but in truth, the two are often bound together. The terrifying beauty of the unknown is that it reminds us how small we are, yet how grand it is that we can even ask these questions. That we can look into the sky, see faint smudges of light, and realize they are rewriting our understanding of existence. What a fragile, improbable gift it is to be a creature capable of wonder, even when that wonder leaves us trembling. So, what are DF2 and DF4 really? Are they scars of violence stripped by a giant neighbor? Are they illusions of distance, products of fragile measurements? Are they mistakes in our models, hints of hidden laws, or lanterns pointing to an entirely new vision of the cosmos? Perhaps they are all of these at once. Perhaps they are none. What matters most is that they exist, quietly, impossibly, defiantly, in the silent darkness. And in their existence, they become mirrors, not only mirrors of galaxies, faint reflections of ordinary forms, but mirrors for us. They reflect our curiosity, our ignorance, our relentless hunger to know. They remind us that the universe is not finished, and neither are we. The terrifying beauty of the unknown is that it will never go away. No matter how much we learn, the mystery will always remain, shifting just beyond our grasp. DF2 and DF4 are proof of that. proof that even in the 21st century, with all our instruments and theories, the cosmos can still whisper secrets that leave us trembling. And so, as we close this journey, we carry with us not certainty, but awe. A galaxy with no dark matter should not exist. And yet it does. Perhaps that is enough. Perhaps that is the gift these silent messengers bring, not answers, but reminders. Reminders that the universe is deeper, stranger, more beautiful than we can ever fully know. And now, let us drift gently into reflection.